Hey, good day, everyone. So today we will be presenting Wilkins, a CERN company aggregate production planning by Eric Paulsen, Carol Prahinsky, and Jenny Deniston. The presenters are Mr. Arnold Padayag and Mr. Amor Pendaliday for our BA 618 Operations Management Case Reporting. Company background: in 1971, CERN Wilkins acquired Wilkins Regulator Company, specialized in producing and selling high-quality water control products for plumbing, tire protection, irrigation, and waterworks. In 1998, CERN merged with U.S. Industries Batten Plumbing Products Company and changed the entire company to Jacuzzi brand in 2003. Its mission was to develop great brands and great products so that they were the company of choice to drive their customer success. The Wilkins division has a 163,000 square foot facility that accommodates the manufacturing operations, engineering lab, and offices of marketing and sales operation, which consists of 12 managers and 33 non-production staff. We also have 52 licensed service centers with over 70 manufacturing sales representatives to provide a wide range of coverage and customer service. Wilkins established itself as a prudent producer with innovative design and quick response to market demands. Doc,
Okay, what are the main products of Wilkins? The company produces two main products, backflow prevention devices and pressure reducing valves. Backflow prevention was a problem in water systems when water that had already been used by consumer returned to the clean water source, introducing potential contaminants to other users. Since water contamination is a public concern, public agency regulated backflow prevention. Backflow prevention device is typically applied in plumbing systems in buildings, irrigation systems, and water system for fire suppression. Now, Wilkins backflow prevention devices was its core product line and accounted for 60% of its company sales. Its most developed and established product under backflow prevention line was pressure vacuum breakers, commonly used in the agricultural irrigation system. It comes in 720 and 420 series. These were made to stock products. Since sales were seasonal with high demands during spring planting season, the company encourages customers for advance purchase while offering sales discounts. Meanwhile, pressure reading valves were designed to reduce or regulate water pressure and temperature in residential, commercial, and industrial use. Take, for instance, a water temperature in a water heater past its set point, the valve will act as a safety device, reducing or eliminating water to prevent the unit from exploding. It is considered a commodity product and accounted for 20% of Wilkins sales. Now, as to the fire valves, it is a kind of pressure reducing valve where used in commercial buildings to prevent backflow from the building's fire control system. A different pressure setting is required to each floor to compensate for the rise in elevation. The recent regulatory changes for commercial buildings were capitalized by Wilkins' marketing team, giving emphasis on its fixed setting fire valves. There is a seasonal demand of fire valves over time as FB or fire valves were being purchased during building construction.
so yeah, that's the main products of Wilkins. So we come up with a case. We will proceed with the case. So the problem statement: Chris Connor, the general manager of the Wilkins plant in Paso Robles, California, has received instructions from the head office to reduce inventory by 30% in the next quarter. Although inventory had been accumulating for the past years, this had been seen as a benefit to the company for a couple of reasons. One is that the cost of raw materials has risen in the past years. The second is that the company has a policy of no layoffs. So having inventory in stock allows the company to minimize the use of overtime and temporary workers. The general manager wondered whether revising the production planning process would be enough to solve Wilkins' inventory problems. Also, a possible adjustment in the workforce and a complete revamp of their forecasting methods. So that's the problem of Connor. So for case question number 1, what is the goal of aggregate production planning?
Okay. Now these are the case questions. The case question number 1 is the goal of aggregate production planning, or APP. APP is a planning process which is mainly concerned with the production requirement to meet the demand levels or budgeted demand. And for that purpose, the requirement of inventory is required to be maintained, whereas the workforce is required to meet the demand levels efficiently in order to match the demand and supply forces over time. So it would be done in 6 to 18 months on the basis of aggregate unit of production for the efficient utilization of available resources. Now, what are the goals of the APP? The first goal is to minimize or reduce the cost production by adopting different production cost-effective plans. Second is to control the losses by adopting good production plan. Third is decision-making regarding different projects and plans. Fourth is the stabilization of organization and smoothness of tasks. And finally, cost-effective hiring and firing processes.
Okay, question number 2. How might app benefit Wilkins? What are the risks associated with the app? So the benefits of app, since inventory management has been an issue at Wilkins, by adopting app, Connor can set up his targets to maintain stock level and to reduce his low material inventory according to the mandate given to him. So, maintain yung stock levels and reduce raw materials inventory. Second, another benefit would be effective utilization of permanent labor force and reducing redundant labor so that overtime and extra costs could be saved. Moreover, there would be no uncertainty of unavailability of component workforce during peak seasons. 3, this app process would be help the company to meet the production demands for PBV because its planning has been abrupt and it had not achieved desired results in sales because of non-planning and inefficient management of inventory as compared to requirement. 4, another benefit would be the reduction in overhead costs, of course, which would ultimately reduce the overall cost. And finally, by efficient improvisation of planning initially on 2 products, the company can evaluate the results and plan for further decisions. So, but also there's also a risk. The risk is that app is a complex process, and there is a risk that they could not have forecast in the best possible way because they do not usually go through this process. And usually this result is unfavorable because this is new to them. There might be an unpredictable outcome. Another risk is that for efficient planning, updated software, latest technology is needed and would entail, of course, additional costs. So this high technology costs will incur if app will be implemented. Third, it could be skewed due to reasons given the breakdown of the machine. On the other hand, the process lacks flexibility, and in a given case, its product fire valves is entirely customized, due to which it might lose its profit by adopting app. Because it's more on machine dependent, app is machine dependent, while they are producing customized product. Fourth, this is commonly staff resistance to change. The staff might be resistant to change because the normal system, they are not yet ready and they are not familiar with app. Question number 3. What constraints are most critical in the development of app at Wilkins and why?
Okay. The question is the constraints that are most critical in the development of APP at Wilkinson, being asked why. The critical constraints in the development of APP can be summarized as under number one, the company is currently not utilizing full capacity of the plant. Second, it is not maintaining optimum production level, as well as it is facing difficulty in managing fluctuating demand. Number three, there is no uniformity in workforce, whereas hiring of temporary workers is habitual, which affects the making of APP. Fourth, planning time is also one of the main concerns. It did not make any plans previously. Moreover, it is inefficient in determining suitable horizon or period for making production plan. Fifth, each product fire valve or the FB is a highly customized product, due to which efficient planning for its production is apparently not an easy task.
Next question would be, was reported last week, how to calculate safety stock inventory given the problem. Calculate the suggested safety stock inventory level for pressure vacuum breakers, PVB, for each quarter using the formula. I have not, wait. The computation has been reported by Sir. Together with question number 5, assuming that overtime is not an option, create up to 3 aggregate production plan for the PVB product family, 1 utilizing a chase strategy, 1 utilizing a level strategy, and 1 utilizing a mixed optimal strategy. If the chase and level strategies are optimal, interpret the results. What are the benefits and limitations of each result? I just show some computations, but it's already been reported by Sir. Given 99 as the, I have not yet attached this one, but in initial inventory, the forecasting for quarter 1, using chase strategy, the total cost would accumulate around 7.6 million using chase strategy. We just discussed the total cost, cost of hiring, holding costs, and the total production cost for each strategy, so that we could answer the question number 5 and 6. So chase strategy 7.6, level strategy is 7.8. This one. And mix strategy also around 7.6, more or less. Slight difference with chase. Okay, so that's the total cost. The formula is computing the production cost together with the regular production and cost of holding costs, so total cost per quarter and total cost of the plan. So we'll back to the presentation. So what are the advantage of chase strategy? It reduces, of course, chase strategy reduces the inventory. So Connor could respond to the requirement of the company. It is most responsive strategy to the changes in the customer demands. It is the lowest cost, almost equal to the safety stock inventory. Disadvantages that the no layoff policy has to be removed. Since it is their policy, Chase has to remove that policy. Low inventory problem may arise. Current PVV cell cannot adjust to its strategy. Challenge of meeting customer demands. However, at the same time, on level strategy, the advantage is it's a feasible solution, can continue the no layoff policy. However, the disadvantage, because of the fluctuations of demands, the inventory level are high. It is the most expensive strategy compared to the three. The cost of material may go down. So as to question number 6, as Connor, would you choose to implement an aggregate production plan? If so, which strategy would you suggest and why? If you would choose not to implement an aggregate production plan, are there any additional changes that could be made to reduce inventory and improve inventory control at Wilkins?
Okay, if I were Connors, there would be certain things to consider before choosing to implement the APP. Probably considering all factors such as benefit, risk, and constraints that are critical in the decision making. The timing of the essence. The timing is of the essence, rather, though it is evident that the APP would make a difference in achieving its objective. Immediate implementation of it could probably result to unfavorable outcomes. If so, chase strategy would be highly recommended due to the following reasons. Number one, there is a high need to cut down the inventory level by taking into consideration the overtime, the subcontract, and other alternatives. Second, it also has the lowest production cost. Third, inventory is the same with the safety stock. And fourth, this should be more responsive to customer demands. And if not, there are some options to consider that might improve Wilkins' inventory control and achieve its target of reducing its inventory. Like, for example, number one, initially provide training to production staff on how the APP and its changes may benefit them. Second, put more emphasis in planning and estimating forecasts instead of using sales history alone. Uh, Third, develop an inventory tracking system and maintain good relation with the suppliers and distributors. And finally, fourth, the vendor management inventory or VMI system can be used to manage the inventory. So I think that would end our report, and taking into consideration that report is not really related to us because we are not producing anything like those. We are just consuming those products. uh, it would be beneficial if we could learn furthermore from it deeper in some other time node. So I thank you very much for this opportunity and for our classmate Chris for facilitating this event and for recording it for us. So now,
Yeah, again, thank you. Unfortunately, we could not correlate it with our personal activities. We do not engage in productions for the past, I think for me itself, for the past 20 years, I have not been in the production process. So I cannot relate it much. But the use of app, the use of a chase level and strategy level, I could relate it to to a production business soon or later. Hopefully, we could use it once we could produce a production business in the near future. So maybe this is just a learning step for us. So again, thank you, Miss Chris, for facilitating us for this report, and thank you, Doc, for we could complete our report too. Thank you.